Hello class, this is Mr. Goodman, and this is lesson 4.4, cosine law. So, what we did in the previous lesson is we learned about sine law. And no, there is no tan law. I get asked that question a lot, at least not that we use. So, sine law is used to solve for non-right angle, missing information in non-right angle triangles. But what happens if sine law fails? And what I mean by that is, here's a triangle, here's some missing information, and we want to know the x. That's what we want. Here's what we know. Let's pop it into sine law. And what we have here is a variable, and a variable. We can't cross multiply anywhere because we have more than one variable no matter what we cross multiply. So therefore, sine law fails. What I'm going to say is that if you're given a non-right angle triangle, what I want you to do is to think pretty much first that you're probably going to use sine law, unless you know you're going to use cosine law. Because what will happen is if you use sine law, and it's supposed to be cosine law, you'll just get stuck. And then you'll be like, okay, it's cosine law. So that's the way I kind of want you to approach non-right angle triangles. So it's cosine law. This is what's often given in textbooks. So this, or this. Well, what the heck does that mean? First off, I'll remind you that if this is angle A, the opposite side is lowercase a, and C and B and B. So you can see here capital A, these are the angles, and these lowercase letters are the side lengths. What makes cosine law challenging is that it depends what's missing. So if you're missing an A value, whether it be a side length or an angle, you're going to use this formula. That's bookended by these two A's. If you're missing the B, you'd use this one. If you're missing the C, you'd use this one. Now, lucky for you, in this pandemic, you don't have to memorize these things, but in a normal circumstance, I would have students memorize something, and it wouldn't be this. It's this I would have them memorize. I'd say, look, the structure of cosine law is always going to be your missing side length, or the missing side length squared equals the other two lengths. So if you're missing B, the other two is A and C, minus 2, and then the other two lengths. So again, if it's B, AC, AC, or if it was C, AB, AB. Get it? Now, if you're missing, let's say, side length A, here, the opposite angle of the missing side length goes there. And that's it. So in this case, A is missing, so in A, lowercase a, uppercase A goes there, BC, BC, and that's the formula. And you'd actually have to have this memorized. So thankfully, I guess one of the good things of this pandemic is that you don't have to. So let me run you through an example here. Here's the triangle. It's the same one actually from above. And what I'm going to do is first just write out the equation itself. So I'm taking the first one here. And writing it out, I'm putting brackets on this B and the C just to show you that it's multiplication. And I put all the information in. So B and C, it doesn't matter if you mix them up. It's 12 and 15, 12 and 15. And it's always cosine because it's cosine law. Cosine 28 degrees. And our missing value isn't called A, it's called X here. So 12 squared plus 15 squared is 369. And 2 times 12 times 15 is 360. And then that 360 times cos 28 is that. Those subtract each other. And we're actually going to, I don't show it here, but I should, square root both sides, and then that's our answer. And this is a side length, so I know that creates both a positive and a negative 7.2, but we're going to ignore the negative because there's no such thing as negative lengths. And that's pretty much how you do cosine law. Easy lesson? Well, it's not over yet, but yeah, it is. It's not so bad. So here's just another example. And it's very similar to the other one, except instead of using A, B, and C, we're using D, E, and F. Well, it's the same concept. Whatever's missing, in this case a lowercase e, the E and the E go on the end, the F and the D go on the inside. So that's how we set it up. I want to also point out to you that what's going on here is what I like to call a SAS situation, which is that we have an angle, a known angle, contained by two known sides. And for me, that's a giveaway that we're going to have to use cosine law. Again, you don't have to. You could always just try sine law first, but it's nice to know relatively quickly you got a SAS situation in front of you. I'm not going to go through this whole thing. It's the exact same as the other one, and we end up in the same place. But I will go through this one down here. So here's another one. And we have 3 known side lengths, and we're looking for an angle. Sine law fails at this. They cannot give you an answer. So I would call this a situation, or just 3 known sides. And again, what's missing here is we have side length B, but we don't know what angle B is. So B is where the missing information lies. So I'm going to put my lowercase b here, my uppercase B here, A and C, A and C. And in this case, I know lowercase b is 15, but I don't know what cosine B is. And the algebra is just a little bit more tricky, so I'll just kind of run you through it. 16.5 squared plus 10 squared is that. 2 times 16.5 times 10 is 330, it's that. And now at this point, from this line to this line, I want to be very, very careful here. This is one piece of information that I just circled. It's like 2a. So I'm going to take that, move it to the other side. Now it's positive 330 cosine B. This positive 225 goes to the other side. Now it's negative 225. That's the big mistake that students make with this question, is not recognizing that. And they're like, oh, 372 minus 330, I know what that is. No, you can't do that. They're not like terms. At this point, these two subtract, become 147. And then we divide both sides by 330. And what we're left with is cosine B equals this, which is a decimal. In fact, it's a trig ratio. And you know how to convert trig ratios. We've done this before. Again, second function cos, decimal 4464, and there's our 63.5. Okay. All right, just get that back. All right. So that's what we've got. Down here, here's sort of a combination type question. It's asking for the area of this triangle. Well, in order to know the area of this triangle, we need to know the height. But in order to find out the height, which would be of a right angle triangle, we would need to know an angle. We need to know this angle would help. Here's an angle, that's the opposite, that's the hypotenuse. We could solve for that, but we need that angle. So we need an angle, that's cosine law. So F is our missing angle, so F and F. There's the E and the D, the E and the D. Put all our information in and get down to this point here. Again, that negative 59.5, that's going to go to the other side, become positive. That 26 is going to go to the other side, become negative. And we end up with 59.5 cosine F equals 35.4. Again, that's the 61.4 minus that 26 to become that. Divide both sides by 59.5. Oops, sorry. And what we're left with is that trig ratio and that number of degrees. Well, if that's the degrees, sine 53.5, our opposite is unknown, our hypotenuse is known, so there it is right there. Cross multiply, x equals 3.9. Well, the question asks for the area of the triangle, so that's base times height, 6.2, times our answer, divided by 2. So the answer is 12.1. Phew! So that's it. That's the lesson. That's cosine law for you. What I'll do is I'll assign just a couple questions from here. I'm finding that the photocopying, I mean, that by the way, that says 40 degrees right there, but I'm finding that by photocopying this and then uploading it, like some of the information is a little hard to read, so my bad. What's easier to read is over on this side. And I'm going to assign these questions as well. And this is application of cosine law. What makes this a little bit easier is that you know every question is going to create a non-right angled triangle that's going to be solved by cosine law. So that should make it a little bit easier to solve these, and the answers are, of course, down below. That's it. That's all I got for now. The special feature for today is me bowling when I was 5 years old. And what I like about this picture is that I'm the exact same age here as my oldest son Alec is right now. And one of the cool things about being a parent is just looking at your kid and being like, I wonder what I looked like when I was exactly that age. And then you kind of take a picture of yourself, you hold it up to your kid, you see what features you won with against your spouse, what features you lost on. When it comes to me and my son, my oldest son, my wife, Mrs. Goodman, definitely won out, as I see it. He looks a lot more like her. But that's okay, because she's pretty, so that's fine. However, my youngest son, Jack, I really think looks a lot like me. So maybe that'll be the special feature next time. Then again, yeah, you don't know what they look like, so you wouldn't be able to judge that yourself. But I'll still put it up here because, I don't know, I like to do something. All right, that's it. I hope you're all doing well and that you're enjoying trigonometry. Again, this is all review, and what I'll say is that we've got just a little bit more of this, and then we'll get to the trig functions soon. Okay, Mr. Goodman, signing off.